Hello everyone, welcome to High Tech Study Plus. This is the first part of our video on the chapter Light, Reflection and Refraction from class 10th Science. So let us begin. Now, in our day-to-day life, we are able to see a variety of objects in the world around us. But when it is dark all around, we find it difficult to see an object. But when there is light, we are able to see a lot of things. So what makes these things visible, or what enables us to see the things? It is nothing but the reflection that enables us to see these things. Let us discuss how. Now, when light falls on an object, the object reflects this light and our eye receives this reflected light. So we are able to see the objects because of this reflected light. So now let us discuss what exactly is reflection. Reflection refers to the phenomenon of bouncing back of light or returning back of light to the same medium after striking a polished surface. Now let us consider Mn to be a polished surface and the red light to be a ray of light which falls on Mn. So after falling on Mn and striking Mn at point P, the ray of light gets reflected, and to just distinguish between the ray of light incident on the surface and the ray of light reflected, I have taken it in a green color. So let this be the light which is reflected. So these two rays are called by specific names. This ray which is incident on it is called the incident ray, and this ray is known as the reflected ray. Now the incident ray strikes the plane mirror or the polished surface at point P. So now if I draw a line which makes 90 degree with this surface, then this line is known as the normal. Here the dotted line is known as the normal. Now let us discuss about the laws of reflection. First, the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane, and the angle of incidence is equal to the angle of reflection. The angle between the incident ray and the normal is known as angle of incidence and is represented by small letter I. The angle between the normal and the reflected ray is represented by small r and is known as the angle of reflection. So as per the law of reflection, angle I is equal to angle r. Now let us move towards the properties of image formed by plane mirror. Now the image of an object is always erect in a plane mirror, that is, the object is always upright. It is a common experience that whenever we see our images in the plane mirror, we always appear to be upright. We do not get an image which is inverted. So the image formed by a plane mirror is always erect, and the image is also virtual. This means that we cannot capture the image on a screen, and the size of image is equal to the size of object. So whenever we see our images in the mirror, then our image appears to be of the same size as us, neither small nor big, and the image is laterally inverted. Now whenever we see our image in the mirror, our right appears as the left of the image and our left appears as the right of the image. So the image is laterally inverted. Now these are certain properties of image formed by the plane mirror. Now suppose Mn is a plane mirror and the box on the left is the object, then this box on the right represents its image. Now let us discuss about spherical mirrors. Now, the reflecting surface of a spherical mirror may be curved inwards or may be curved outwards. So, if the reflective surface is curved inwards, then the mirror is called as a concave mirror, and if it is curved outwards, then it is called a convex mirror. Now, in the figure A, this part is the reflecting surface and we see that it is curved inwards. So, this is concave mirror. In the figure B, this is the reflecting surface and it is curved outwards. So, this is a convex mirror. Now, let us discuss certain important terms before we move towards ray diagrams. So, the first and foremost important term that we need to understand is pole of a mirror. Now, the center of the reflecting surface is known as the pole of the mirror and it lies on the surface of the mirror. Let us consider this figure A. This reflecting surface will have certain center. Let this be the center. So, this is the pole of this mirror. So, that point is the pole of the concave mirror and it is represented by capital letter P. In addition to this, the reflecting surface of a spherical mirror forms a part of a sphere. The center of this sphere is known as the center of curvature and this center of curvature is not a part of the sphere. Now, let us consider this figure C. As we can see here, the reflecting surface of the spherical mirror forms a sphere and this sphere has certain center. Suppose this is the center, it is the center of curvature. As is clearly visible in the diagram, the center of curvature does not lie in the spherical mirror. So, the center of curvature is not a part of the mirror, but the pole is a part of the mirror. Suppose let us consider this is the pole P. Now, let us consider figure D. In figure D, we have done the same thing and this sphere has also got its center. Let this be C and this be P. So, the center of curvature is not a part of the mirror and in case of convex mirror, it lies behind the mirror. As we can see here, this is the reflecting surface and center of curvature lies here. So, center of curvature is behind the mirror in case of convex mirror and in case of concave mirror, it is in front of the mirror. Now, this sphere also has certain radius. This radius is known as the radius of curvature of the mirror. Now, if we draw a straight line passing through the pole and center of curvature, then it is known as the principal axis of the mirror. Suppose this is a spherical mirror. Here is the pole of the spherical mirror and here is the center of curvature. Now, if I draw a line like this, then this line is called the principal axis. Now, let us discuss about the focus of the mirrors. Rays of light incident on it will reflect back. So, let us consider this ray 1. A ray of light is parallel to the principal axis. Here this is the principal axis. Suppose this ray of light 1 gets reflected in this way. The ray 2 gets reflected in this way. Ray 3 gets reflected in this way and ray 4 gets reflected in this way. So, these 4 rays after reflection they meet at certain point and this point is known as focus of the concave mirror. So, the focus of a concave mirror is a point on the principal axis where all the rays of light after reflection converge. So, this is for concave mirror. Now, let us discuss about convex mirror. So, this is the Now suppose we incident ray 1 on it, then it will get reflected in this way, ray 2 will get reflected in this way, and if we produce them backward they will meet at a certain point, and this point is referred to as the focus of the convex mirror. So for a convex mirror, the focus is a point on the principal axis where all the rays after reflection appear to diverge from. So this is the definition of focus for a convex mirror. Now the diameter of the reflecting surface of spherical mirror is referred to as the aperture. In our discussions we shall consider only those spherical mirrors for which the aperture is less than that of the radius of curvature, and for small apertures this R, radius of curvature, is equal to twice the focal length. That's all for today. In our next class we shall continue with this.